I made 3 of those crank discs because I'm making several versions of this engine. But you can also make your crank discs something like this. Now that's out of aluminum. I used to make little castings so it won't match with the brass. But that kind of simulates a counterweight, and the appearance is quite pleasant too. Maybe more so than the disc itself. But take a look what I did on these discs now. They are reamed 3/16 in the center, and I laid out, if we can get the light right here, on a center line, 1/8 inch, well actually it's 3/8 of an inch from the center, which puts it about 1/8 of an inch from the edge. I center punched it. Now that's going to give me a 3/8 throw, or you could say a 3/4 stroke. You can vary that if you want, but then you might need to make this a little bit bigger. And then the second step was, of course, I pre-drilled it with 1/16 inch, and finally I drilled it 1/8 inch. And you may need to drill it a little larger, that is a number 30, which is just a few thousandths bigger, if you're going to use Loctite. And I'm going to use Loctite, so mine's just a little bit bigger. Or polish the end of this, and this 1/8 inch brazing rod, and that is about a 1/2 inch long. So I'm going to, before I eat lunch, I'm going to put that in there with some Loctite. An alternate is to press it in. Drill just a little bit smaller, or ream smaller, and press it in. And then also, while I'm at it, there's the crankshaft. And I'm going to hold that in with Loctite. Now if you do not like Loctite, make this a little thicker. And the alternatives are to put a set screw in there, but that's kind of awkward to do. You can also thread the end of this and tap this and screw it in. Probably a drop of Loctite so it can't spin loose if you're running it in the opposite direction. So there's all different ways of doing that, but the Loctite for me is tried and true, and they never do come loose. And if you should you have to get them loose for whatever reason, you can heat them just a little bit with your torch, and they'll slide out of there for reassembly or reworking or whatever you're doing. So I'm going to do that before lunch, and then it's ready to work on. Doesn't take too long for the Loctite. Pre-clean it for Loctite. They do make primers. I don't mess with that, but this is Loctite that is used for press fits or bearings. Don't use the blue stuff. It's used for threads. Do not attempt to drill in this manner because the work is going to get loose on you and spin on you. Now make sure you got glasses on and you work safely. Also, if you just try to drill this on wood, it tends to cock a little bit. You wouldn't think it would on hardwood, but sometimes it just tips a little bit. So the way I like to do it is I got it mounted in a vise, and I've got it positioned such that I will drill through the vise and not into the vise. And I had to change drill bits because on the first one that bit just wouldn't go anyplace because of what I had told you earlier. And just drill slowly, hang on to the vise, and reduce the pressure as you break through. And you can see how I missed the vise. Don't be a hammer and chisel mechanic and drill into the vise. Sometimes you look at these vices and they got a million holes in them. Well, time has come to tackle the cylinder, which might be considered the most difficult part, but we're going to get started on it. And the material is brass, of course, and it's 3/4 thick by 1 inch. Now you're not going to find material that size, so what I did is I got some 1 inch stock, and I'm going to mill it down to 3/4 thick. So with my height gauge already set, and before you do that, take your file and dress on all 4 sides the piece, because this is a piece that's been sitting around here for a long time, and you can see someone had bead on it, something I got at an auction. on both sides. So in reality here, I'm going to have to take a light cut off of one side and then come back here, lay it down, and I'm not going to show that, and then scribe it 3/4 of an inch. Now sometimes I just set my scriber, and this is a vernier, which I don't like reading, I prefer the dial caliper, but sometimes I just set these by taking a piece of 3/4 stock, and I measure that as 3/4, and just adjusting it so it comes up onto the 3/4, or you can use your combination square, or you can just rough mark it and then put it in the mill and start milling away, and then take readings with a micrometer and take it down to 750. But that dimension is not very critical at all, and it is to be 1.5 long. I'll make it just a little bit longer than that, so I'll mill the end off while I'm at it, because these are just saw cut. And I've got enough material here to make 1, 2, and then a third one. Now what I've done here, and I prepared this some time ago for a job that I was going to do, it was already 3/4 thick stock, or close to it. I took a piece of 1/4 inch brass, about like this, probably was a piece of this, cut it off the length, and then I sweat soldered it onto there. Can you see the solder joint? There's some solder showing right there. And then after I did that, then I put it on the mill and milled it down so it was smooth on both sides. So you can make up a piece if you don't have the right size. You can make this out of steel. You can make it out of aluminum. But I'm stuck with brass here now. So that'll appear in a later one, and I've already milled one end of that. So off camera here, I'm going to take this to the mill, clean it up just on one side, and then do what I just told you. Okay, this is the side I milled down. So it's true, it's clean, it's not the best cut, but some things do not matter. Now I will mill it down to the line. That'll make it 3/4 thick, and then I'm going to saw it off at the red line. This is waste stock here, so you can see what the actual cylinder will be. And then I'm ready to remill this side that'll have a saw cut, and that's the side that I will do the boring with, and then we'll drill and ream the hole, the main cylinder hole. And that I'm going to do in the milling machine. Now notice the flutes weren't quite long enough here to clean up this side, but that doesn't matter, or this end rather, because that's going to be milled off and gone. Now you'll notice that a lot of times when you find a piece of brass, and I get this stuff at auctions, it's often used with a hammer to pound something else down. So you see a lot of abused brass, but you get it real cheap. And here's another typical drift where somebody has used it to pound, but sometimes you get these for next to nothing because people don't even identify them as brass because they're tarnished, plus it's beat up, so nobody wants it except the scrap man and me. Here I am at the Bridgeport, milling it down to the thickness of 3/4, and I think you can see the layout line. And I won't do the whole thing. It's a nice sharp end mill, and it sure is cutting nice. That's nice brass, whatever alloy it may be. Then when I get near the line, I will check the thickness with the micrometer. Use a chip brush, don't put your hand near there. I'll measure the thickness with the micrometer and determine how much oversized I still am, and then just raise the table, whatever that amount is, and get it right at 3/4. Not that that is all that important of a dimension. It's right down to thickness, virtually. 751, just a thousandth over. The only reason I want this fairly close to dimension is that then when I go to locate the center for that hole, I don't have to do a lot of other math in my mind. Now the reason I have the work hanging over to the edge, normally I work in the middle of the vise, and it's not a good practice to pinch it in one end of the vise because the vise jaw cocks. Although I don't really want to get into all those advanced things here, because this is a simple job for, I hope, beginners. But that allows, the hangover there allows me to mill the end here, which I'm going to do next, and to square it up and take it to that line so it's 1.25 inches long. And I like to finish, take my last pass by climb milling. It always gives me a little bit better finish. Now if you do not have a milling machine, all of this can be done with saws and files and belt sanders and so on, but of course this is a machine shop course, so that's the way I'm doing it. But just to be sure, there are so many ways to skin a cat. I was having a little trouble with that Mitutoyo height gauge, and you might say, well, that is the Mitutoyo height gauge. No, it isn't. This is one I bought well over 10 years ago for $55, and it's been in stock ever since, and I don't know what I'm saving it for, but I'm pressing it into service right now, and you can still see it's got the protective wax on there. So it's going to take me just a few minutes to peel that off, and still got the wax on the scriber. But it's just a little bit different than that other one. Now, this has a slightly smaller dial, and the dial is on the opposite side. So in other words, the other one had the dial here, where it was a little easier to read. So I don't know, this must be made for left-handers. But I'm going to clean it up, press it into service, and go ahead and lay out this cylinder block now, which I've got the layout die drying and just about ready to go as soon as I get this thing done. It took me 15 minutes to get that protective wax off, and it's still not all off. I guess this has been in storage so long that had hardened, and I'm used to peeling that right off like you peel a banana, but that was one heck of a job, and that was using a little handy knife, and I got the bottom all cleaned and a little bit of oil on it so it slides, and the plate clean, and what a nice sharp scriber that is. It's set for 3/8, .3750. Carbide tip. And that is where I'm going to drill and ream the hole, the main bore. And you can see it's off center. Why is it off center? Because we need room for the ports on this side and the stud, the screw that is threaded into it where it pivots. So it can't be square, it needs to be rectangular, and you can see I achieved that on this one by making a saddle that I soldered the tubing to. That's an alternate for you to make it that way also, depending on what tools and equipment and know-how you already have. Let's go over to the milling machine and talk about drilling and reaming. I'm at the Bridgeport mill preparing to ream the 1/2 inch bore here in the cylinder. The tools that I'm going to use is a small center drill, 1/4 inch pilot drill, a 31/64, which is a 64th under a half, and this is the 1/2 inch chucking reamer. Notice that I have the work held up a little bit off the bottom of the vise with a parallel, so when I drill all the way through, I'm going to slide this out of the way so I don't drill into the parallel, but yet also will not drill into the vise itself, because there's already several holes in there. If you do not have a milling machine, this can be done on the drill press. Just be careful that the work is fastened properly, because a drill like this can tend to grab. There's all different kinds of ways of locating the spindle in regards to the crosshairs here, and I did not center punch this, but we also could use edge finders and different ways that some of you maybe are not familiar with, but I've shown them in other videos to locate that mathematically. So many, 3/8 in by 3/8 in. But I'm going to use a wiggler here just with a sharp point, or you could just go in with this, but here's a pretty accurate way of doing it. Now I have to turn the machine on. and I put something against the wiggler until it runs true, just like that. Then I locate it in this manner. Until that's right on the crosshairs. Then I'll lock the table in both directions. I'm going to use the digital readout too, and I will zero it out just in case I need to move the table back and forth in order to change tooling, because these reamers are so long that sometimes I have to either drop the table farther or I move the table out of the way so I can change the tools. I've got a 1/2 inch chuck in here so that all of these tools will fit in that chuck and I don't have to change the work holding device. Always start with a center drill or a starter drill. They're short and stubby and will not deflect. Note that I took the hardened parallel out of there so I don't damage either it or the tool. Did you see how that bit grabbed and pulled in? But it didn't go in very far because the center drill wasn't that deep. Keep clearing your chips. Get those chips out of there. And I'm already through. My critics are most harsh on me, as are the trolls, for using the wrong speeds from time to time, but that's usually by design, and this in fact is again the 31/32 bit, and I'm using it at a speed of 1750, which is probably a little too fast, but I have a J head with step pulleys and it's no fun changing the speeds, and I do have to slow it down to use the reamer, so I'm not going to change the speeds twice, so you have to bear with me. The bit isn't any too sharp. And I'm through. I really had to drop the table a long ways for these long reamers. And I'm in back gears, meaning I have to run the spindle in reverse, or the motor in reverse rather, to get the correct direction on the spindle. But you need to run reamers slow compared to... Whoop. Wrong way, Corrigan. And it's ready to take out. Here's some more of TUBALCAIN's related information, whether you like it or not. These are brand new Christmas tree bits. Do you see why I call them Christmas tree bits? I don't know if I made up that name or if I heard it some other place, but this is a Unibit, which I think is a trade name, but Greenlee makes these. They make all kinds of things for electricians, and they do a lot of drilling like this. These come in two sizes. Here's the smaller one that goes up to 13/16, and there it shows you the sizes, and that's probably exactly what I got here. And then here's a larger one. You know, this is 3 times tougher. That's got 6 sizes and goes clear up to 1 3/8. I haven't used it yet. It's still in the box. That's a very expensive tool, but I just wanted to show you what they look like if you see them on the rack in the stores. That's what the cylinder looks like so far, and I had quite a burr on the end that I had to file off and then remove with my burr remover. And I may belt sand this later on, but for now it's perfectly perpendicular to the bore, so I don't want to change that. And I put some bluing on this surface, and I will draw a center line on there. And the height gauge here is still set for that, so it'll be easy enough. You know, this new carbide scriber scribes deep enough to where it actually produces tiny shavings. And I like that feature because my center punch can follow the furrow. If you've done much work, you know what I'm talking about. I took this other one apart here to show you what it looks like on the back of this cylinder. And never mind this chamfer here, that was one of my experiments on another engine. But we need the center hole here, and that's going to be threaded 540. Now why 540 instead of 632 or whatever? Because, and you might have to change that if you can't find a 540 tap and die, but 5 is an 1/8 inch, and that way I can use that 1/8 inch brazing rod without turning stock down, because a 6 is going to be an odd size that you won't find, and I would like a bare spot here to actually ride in this hole so it doesn't chew it up or act like a cutting tool. And then I will also lay out these two little inlet steam or air ports. Air ports, not airport. Notice that I made this cylinder just a little bit longer. I might have told you I made it 1 1/4, but I made it 1 3/8 because I made this 1 3/8. That gives me just a little bit more room there for my my ports and the recess that my heads will have. You'll see what I mean by that in just a second. So I got the center line there. I will now locate the center this way for the main pivot point here, or pivot, and then I'll tell you just in a second what the dimensions are for these. And you know, I forgot to Loctite this in before because it was loose, but it is most essential. I cannot emphasize this enough. Set my little square here, that this be perpendicular in this direction and in this direction. If it is not perpendicular, you will run into a problem later on after you try to run it. Probably better off showing with this one, that this surface will not rest up against this, and you're going to have air leaks. That's why I'm doing it on the milling machine, and you'll see the way I drill it and tap it and the great care I take, but that is the reason. And a lot of people have trouble with their engine. They're still going to run, but they're going to leak air like crazy, and they always tend to leak a little bit there anyway, but you don't want to aggravate the problem, so take care.